We'll conclude our lecture by giving a brief history of the Internet. The Internet is not a recent development, but an idea that has been around for a very long time. We're talking like 45 to 50 years. The concept actually first took shape during the early and mid 1960s, and it was based on the work of computer scientists at MIT and the RAND Corporation. So specifically, around August of 1962, the idea of the Internet was first proposed by J.C.R. Licklider at MIT. So what he was proposing was building a computer network, and he sent a memo out to several colleagues, which was called the Galactic Network. And so, he described this globally interconnected set of computers through which everyone could access data and software. So he convinced other researchers at MIT, including Larry Roberts and Leonard Kleinrock, of the validity of his ideas. So for like the next 5 or so years, they investigated the theoretical foundations of this area of networking, especially such fundamental concepts as protocols, packet switching, and routing. Now, in 1966, Roberts moved to the Advanced Research Projects Agency, or ARPA. This was a small research office of the Department of Defense, and this group was charged with developing technology that could be used for the U.S. military. So, ARPA was actually interested in packet switch networking because it seemed like a more secure way of communicating during wartime. Now, ARPA funded several network-related research projects, but it was in 1969 when they completed ARPANET, which was with some help from UCLA and the Stanford Research Institute, or SRI. This was the first computer-to-computer network system. So here, the idea was that there were 2 nodes that was initially part of this network, and they were able to actually send and receive messages. Later that same year, 2 more nodes were added to the network. So they added the University of California, Santa Barbara, and the University of Utah. And in fact, by the end of 1965, the budding 4-node network was off the ground. Now, ARPANET grew very quickly during the early 1970s, and it was formally demonstrated to the scientific community at an international conference in 1972. During this same year, the first killer app was developed. And what I mean by killer app, it was a very popular app, and this was the electronic mail. So this was an immediate success and just caused this explosion of growth in people-to-people traffic rather than the people-to-machine or machine-to-machine traffic that dominated the usage in the first few years. Now, the success of the ARPANET in the 1970s led to other researchers developing similar types of computer networks to support information exchange within their own specific areas. So we had things like the HEPNet, which was the High Energy Physics Network. We had CSNet, which was the Computer Science Network. We had the MFE-net, which was Magnetic Fusion Energy Network. Even corporations were starting to notice the success of ARPANET and began developing their own networks to market for customers. So we had some examples from IBM. We had some things from Digital Equipment Corporation. So, the 1970s were a time of rapid expansion of networks in both the academic and commercial communities. Now, because there were all these different networks out there, researchers at ARPA realized that there was going to be a potential problem in that this rapid and unplanned proliferation of independent networks would lead to incompatibilities and prevent users on different networks from communicating with each other. And this was a problem. If we have all these different networks, it doesn't do any good if they can't talk to each other. So they knew that in order for this to work, we had to have a way where all networks would be able to communicate in some standardized fashion. So the researchers developed this concept of internetworking, which stated that any WAN is free to do whatever it wants internally. However, it must use a common addressing scheme and identical protocols whenever we're at the point where 2 networks meet. In other words, they have to speak the same language. So what we're saying here is all these separate networks, they can do whatever they want internally. but at the point where they're going to communicate with each other, they have to use the same addressing scheme and protocols in order to communicate. Now, the way this worked, there was a device that's called a gateway that helped with making these internetwork connections, and they provide a routing between the different WANs. So we started to see some research into solving this problem of being able to communicate with different networks. And it was in 1973 where we saw the development of both the hierarchical host naming scheme that we use today and the TCP/IP protocols that are the common language spoken by networks around the world. And during the late 70s and early 80s, we started to see work being done on implementing and installing TCP/IP not only on mainframe computers, but they were also being installed on the PCs and desktop machines that were just starting to appear in the market. Now, by the early 1980s, TCP/IP was being used all over the world, but even around that time, we were starting to see exciting new applications appearing that were designed to meet the growing needs of the network community. So we saw things like Telnet, which allowed users to log on remotely to another computer and use it as if it were their own local machine. We started seeing FTP, File Transfer Protocol, as a way to move files around the network very quickly and easily. So along with email, these and other applications just expanded the network just so much, so vastly. Now, there was one more step that was needed to help with getting the internet off the ground. And this was done in 1984 by the National Science Foundation, or NSF. And they developed what was called the NSF Net. One of the issues with the network prior to it is that there really weren't that many people using it. And this was because in order to use the ARPANET, you needed a research grant from the U.S. Department of Defense. So, I mean, people were using the internet, but they were used exclusively by physicists, engineers, and computer scientists at a select set of secure military and research centers. So, I mean, not everyone could use the internet because you can only use ARPANET. So this is where NSFNet came into play, because this was developed and designed to be open to universities, government agencies, libraries, museums, schools, and so forth. By the late 1980s, we started seeing all these different types of networks connecting with each other. In fact, sometime during this time, the term ARPANET ceased to be used because the ARPANET was now only one of many networks belonging to a much larger collection. So in fact, people began referring to this entire collection of interconnected networks as the Internet. And although this name was not officially accepted until around 1995. But I mean, once the public had easy access, the Internet just became this immediate success and grew rapidly. By the middle of 1993, I mean, it included 1.8 million host computers, and it had roughly about 5 to 10 million active users. And the size was just doubling every single year. In fact, it became so successful that the NSF decided that it was about time to get out of the networking business. The goal of the NSF was just to fund the basic research, not to operate the whole thing. So around 1995, specifically in April of 1995, the NSF Net closed up shop. And what this does, it created business opportunities for new firms called internet service providers to offer internet access that was once provided by the ARPANET and NSF Net. So we just started seeing internet service providers being able to take over and started seeing an area of commercial use. We'll now take a look at, just very briefly, the history of the World Wide Web. This actually started in 1989 by a guy named of Tim Berners-Lee. He was a researcher at CERN, or CERN. I'm not too sure exactly how it's pronounced, but we're just going to go with CERN for now. And this was the European High Energy Physics Laboratory in Geneva, Switzerland. So this guy first developed the idea for a hypertext-based information distribution system. Now, because physics research is often done by teams of people from many different universities, what this guy wanted to do is create a way for scientists throughout Europe and North America to easily and quickly exchange information, such as research articles, journals, and experimental data. Now, they could have used existing internet services like FTP and email, but Berners-Lee wanted to make information sharing easier and more intuitive for people that are unfamiliar with computer networks. So beginning in 1990, Berners-Lee designed and built a system using the concept of hypertext, which is a collection of documents that are interconnected by pointers, which we call links. The whole point here is that these documents were meant to be read linearly from beginning to end, but users of hypertext documents were free to navigate the collection in whatever order that they wanted. So they could use the links to move freely from one page to another. So Berners-Lee actually reasoned that the idea of hypertext matched up very well with the concept of networking and the internet, because hypertext documents could be stored on the machines of the internet, and then a link would be the name of the page along with the IP address of the machine where that page was stored. So he called this hyperlink text the URL, which we've already talked about earlier on. So this system that he developed was named the World Wide Web. He called it the World Wide Web, and it was completed and made available to all researchers at CERN in May of 1991. So this particular day marked the actual birth of the web, and it became an instant success. And traffic on the CERN web server increased just by 1,000% in just the first couple of years of use. So in April of 1993, the directors of CERN realized the benefits of using the web and realized that the impact it could have on research throughout the world. So they announced that effective immediately that all web technology developed at CERN would be freely available to everyone without any fees or any royalties. So for many people, this announcement really marked the emergence of the World Wide Web on a global scale. And then this just led to the advancements of different types of web browsers that were being developed. One of the first ones was called Mosaic. This led to other browsers such as Netscape Navigator, Internet Explorer, Safari, Firefox, Chrome, and so forth. And it led to the browsers that we see and use every day.